The last lesson introduced Gestalt psychology's approach to object perception. In this lesson, we will continue to explore this approach and focus on grouping principles and figure ground perception. Gestalt psychology actually proposed some specific laws of perceptual organization and grouping principles. One of these principles, which really encompasses all of the other principles, is pragnanz, meaning good figure. It captures our strong bias to see what is simple and regular. In the figure on the left, for example, you are likely to see 5 complete rings rather than the more complex shapes displayed on the right. We have the same exact parts in both figures, but you can see that our tendency is to perceive the simplest shape, which would be the whole rings. All of the other laws we will talk about next follow this minimum principle of simplicity. One of the grouping principles of Gestalt psychology is that of similarity. We could view these shapes in multiple different ways, but our inclination is to see stripes running as vertical columns. That is because we tend to group the similar objects together, in this case the circles with the circles and the squares with the squares. Here are a couple more examples of grouping by similarity. On the left, all of the shapes are pink, and all of them have little faces on them. But we still tend to group the circles with the circles and the triangles with the triangles, resulting in the perception of a larger triangle within the middle. And on the right, we have a figure referred to as an Ishihara plate. These are used to diagnose color blindness, and we will return to these later on when we talk about color vision, but they work because of grouping by similarity. If a person can perceive the difference between the orange and blue dots, then they should naturally group the orange dots together to see a 25. However, individuals with certain forms of color blindness may not see the difference in color among the dots, and they would therefore not be able to group the dots forming the 25 together. Another Gestalt grouping principle is grouping by proximity. Things that are near each other tend to get grouped together. Here we tend to perceive vertical columns of dots since the spacing above and below the dots is smaller than to the left and to the right of the dots. If we make the spacing the same between all neighboring dots, we no longer see the columns. But if we increase the spacing above and below the dots, we perceptually group the dots that are to the left and right of each other and start to perceive horizontal rows. Now, if we equally space the dots again and make some of them a different color, we again perceive vertical columns. But this time we aren't grouping by proximity because all of the dots are equally spaced from one another. We now have grouping by similarity again because the orange dots are similar to each other, as are the yellow dots. Good continuation is the principle that when points or lines or objects are intersected by something, we tend to perceive them as continuing on underneath or behind the intersection, so long as they are aligned in such a way that would allow for a smooth connection. So on the left, it is easy to imagine the line continuing on behind the square because the pieces that we can see could be connected by a simple straight line to form a smooth connection. However, on the right, we don't tend to see the two lines as being connected behind the square as easily, since it would take an irregularly shaped, more complex line to connect the two pieces. The key with good continuation is whether or not the pieces are aligned. Here is another more complex example of good continuation, where we can perceive the whole baby even though part of it is covered up. This covering up is also referred to as occlusion. Occlusion is when one object is in front of or is otherwise covering up part of another. And good continuation is the grouping principle that allows us to perceive the entirety of an object that has been occluded. Closure is the grouping principle that allows us to perceive objects as entirely bounded, even if there are gaps in the object. Everything that is an object is considered a closed form. And so sometimes when we only have pieces of an object, we have the tendency to perceive it as being a complete object. On the left here, we are more likely to perceive a complete rectangle than just some lines and corners because of the way the pieces are aligned. On the right, we tend to see two triangles, one with a blue outline and then a white one on top of the blue one, and on top of three blue circles. We know there is physically no triangle in the image, but because of the way the pieces are aligned, because of that relationship of the parts that we talked about in the previous lesson, we perceptually close up the lines to perceive whole bounded triangles. The grouping principle of common fate occurs when objects are moving together. Here we have some dancers that are moving together. Well, this is a static image, but you can imagine them all moving together. So we would likely perceive them as a group, as we would a flock of birds flying together in a single direction. There are many more Gestalt grouping laws, but the last one we'll talk about is grouping by familiarity or meaningfulness. We are likely to group things together that form a meaningful or familiar pattern. This picture here by Bev Doolittle is pretty amazing because the longer you look at it, the more faces you will start to see. The pieces making up the faces are just the rocks and vegetation of the landscape, but because of the arrangement and, importantly, how familiar of an object faces are for us, we easily see the faces embedded within the picture. Here are a few more examples of grouping by familiarity. Another concept developed by the Gestalt psychologists to explain object perception is that of figure ground. Figure ground deals with perceptual segregation, or how objects are separated from the background behind them. In these two figures here, the job is to determine which is the figure and which is the background. So with the picture on the left, you likely see either a woman's face, which is white with the black being shadow, or a man playing a saxophone or smoking a pipe, which is black against a white background. On the right, you probably see either two black faces facing each other against a white background, or a white vase against a black background. Interestingly, it is very difficult to see both at the same time. You see either one or the other. Once you perceive the figure in one of the two scenarios, the background becomes formless. There are some general characteristics that describe what we see as the figure of the picture and what we view as the ground. First of all, the area that we see as the figure is going to be the part that seems most object-like and memorable or familiar. Also, the figure is going to be seen as being in front of the background. We will actually perceive a difference in depth of the figure versus the ground, even though we are looking at a 2D image. And the ground is seen as unformed and extending behind the object. Finally, the contour or edge separating the figure and the background will always appear to belong to the figure. There are also certain factors that influence which area is perceived as the figure and which is the ground. One of them is to enhance one or the other as the background by putting either a black or white border around the figure. So in this figure, if I add a white border, the white area of the figure is more easily seen as an extension of the background, and we are more likely to see the two faces. However, if we place a black border around the figure, the black area of the figure becomes part of the background, and the vase is the object that we see. Symmetry is another factor affecting our perception of the figure. As we can see here, on the left, the black areas appear to be the figures, and on the right, the white areas appear to be the figures, because the areas with symmetrical boundaries are more likely to look figure-like. And here's another example of the effect of symmetry. Size is another factor affecting our perception of the figure over the ground. We tend to view the smaller area as being the figure. So on the left, it is pretty ambiguous which area is the figure and which is the ground. It's pretty easy to see either white arrows pointing down or black arrows pointing up. However, if we decrease the size of the white areas, suddenly it is much easier to see the white arrows as being the figure and more difficult to see the black as being the figure. We get the same effect here as well. On the left, the figure versus the ground is pretty ambiguous, but on the right, it's much easier to see the red areas being the figure. Another factor affecting our perception of the figure over the ground is meaningfulness or memorability. So in this picture here, we see some black arrows and odd shapes, but if we just add in a black shape to the left and to the right, something completely different pops out. You probably now see the word win in white. Suddenly, rather than the black area being the figure, the white area has become the figure. The reason for this is that words are very meaningful for us, and so it is easy for us to suddenly group the black area together as the figure since it makes out a word. Here we have another example of meaningfulness. Here we have some pictures of mice or rats. And here we have a bunch of faces. But did you happen to notice that one of these pictures is from the previous slide? This picture was on both slides. Chances are, when it was surrounded by mice, you saw this as a mouse, but when it was surrounded by faces, you saw this as a face. When it was surrounded by mice, a mouse was a more meaningful object, so you were more likely to see it as a mouse. And the same is true of the faces. We have one last example here. We are going to try a little demo, and I want you to look at the picture A, because in a moment I will flash two more pictures, B and C, and your job will be to decide which of B and C looks more similar to A. So get a good look at A. All right, now I will show you B and C, but only briefly. Were you able to decide whether B or C was more similar to A? In studies using stimuli like these, participants tended to choose picture B as being more similar to A than picture C to A. Oddly, the black shape of C is more similar to that of A than is B. The reason for this is likely that by adjusting the border of each picture, we affect which area is viewed as being the figure versus the ground. In A, because the border is white, we tend to see the black area as being the figure. However, in B and C, because the border is black, we tend to see the white area as being the figure. So when we compare the figure in each of the pictures, the actual shape of the figure in B, which is the white area, is more similar to the figure in A, which is the black area, than is the figure in C. We could say that this manipulation of figure versus ground is due to both manipulating the background as well as meaningfulness, since the shape of the figure in B is more meaningful or memorable given the shape of the figure in A. We have talked about the receptive fields of neurons and using electrophysiology to measure their activity and determine what types of stimuli they are responsive to. Well, it appears that some neurons within the primary visual cortex are sensitive to figure versus ground changes in perspective. If you look at the figure on the left, you'll notice a box that seems to pop out of the scene towards the right of the black dot, since the little lines making it up are pointing a different way from the rest of the figure. The box appears to be the figure in the scene since its lines occupy a smaller area than the lines making up the rest of the figure. The rest of the figure appears to be the background behind the smaller box. In this experiment, the small green rectangle represents the receptive field of the neuron being recorded. The green rectangle would be considered part of the figure versus the ground since it is on the box that seems to pop out against the rest of the figure. And if we look to the right, we can see that the neuron is firing quite a bit. However, Look at what happens when the little box in the figure moves over to the left-hand side of the black dot. Now the green rectangle is no longer part of the figure, as in figure versus ground. Now it has become part of the background. If we look over at the firing rate of the neuron, we can see that it has dropped significantly. And the orientation of the lines surrounding the green rectangle haven't changed at all. The only thing that has changed is our perception of that area being either part of the figure or part of the background. So what this means is that the neuron fires when its receptive field is part of the figure, but not when it is part of the background, regardless of the actual physical stimulus.